Hello teacher. In this video, a double-ended decoy data structure which supports both query and stack operations has been implemented in Java. The term decoy is shorter for double and decoy and refers to a flexible data structure that allows insertion and removal of elements from both the front and the rear. Since it can demonstrate both stack and query behaviors, it is suitable for various problem-solving screeners. This versatility makes it an essential component in many algorithms, especially those involving block, block tracking, shielding windows, and task scheduling. The underlying structure of this implementation is doubly linked list. A double linked list allows traverse in both forward and backward directions, making it ideal for the queue. The queue class is definite general C at the QT, making it capable of working with different data types like integer, string, or even custom objects. This use of generics ensures that the data structure is reusable and type safe. Inside the class, a nested static node class is created which contains their fields, the data itself in reference to the prev and next nodes. This linked nutter allows a fence operation and both ends of the deque. The deque class maintains darker attributes front, rear, and size. The front points to the first node in the deque, the rear to the last node, and size keeps track of how many elements currently exist in structure. These files play a vital role in managing the internal state of the decoy, allowing constant time complexity for installation and deletion operation of both ends. The add first method is used to insert a new element at the first the decoy if the decoy is empty. A new node is created and both pointers are assigned to it. If the decoy is not an empty, a new node is created and placed before the current front, with all necessary reference updates to maintain the structure. Similarly, the atlas method adds an element at the rear again if the decoy is empty. The name node becomes but front or rear. Otherwise, it is linked after the axis rear node and the rear reference is updated accordingly. When it comes to removing elements, the remove first, remove last methods are responsible for handling data deletion. Remove first checks if the decoy is empty and returns null if so. Otherwise, it removes the node at the front, adjusting pointers and reducing the size by one. If there is only one node, both front and rear are set to null. In case of multiple elements, a front is shifted to The next not and provides not likes is served at the remove list method. It works in a similar way but operates on the rear end. This operation maintains the data integrity while ensuring performance. The peak first and peak last methods allow non-destructive access to elements at both ends. These are useful when we want to check the current state of the decoy without quality modifying it. If the decoy is empty, this method returns null. The is empty method provides a quick boolean check to determine whether the decoy contains any elements. The size method simply returns the current count of nodes in the decoy. A particularly helpful method in the class is print decoy, which is used for debugging and visual confirmation. It travels from the front to the rear of the decoy and prints out each element's data. This method is especially useful when testing operation step by step, as it shows the live state of structure. To verify the correct functionality of the decoy class is a separate class named decoy demo. It has been written within this class. The main method serves as the driver code that tests all functionality. First, decoy integer object is installed in initial checks are performed to see if the decoy is empty. Then multiple values are added using both at first and at last to test iteration at both ends. After each operation, a print decoy is called to display the update contents of the decoy. Further tests involve calling peak first, peak last, remove first, and remove last. These methods ensure that data can be accessed and removed correctly from both ends without compromising its structure. And finally, the size and its empathy methods are called again to verify that the internal tracking variables remain accurate throughout operation. Beyond the basic test screen, a decoy can be, for example, is window uh, of the finality track minimum or maximum values is a subarray. They are also useful is implementing under reader features application where elements must be added removed from both ends as the user navigates backs and forth. Another example is using the quest to simulate call stacks in security algorithms that require backtracking, such as solving mazes or puzzles. In constellation, this project focuses on building a robust and flexible data structure that combines the functionalities of both stack and queries. The decoy implementation supports a constant time addition and removal of elements from both ends, making it efficient and highly adaptable. Such structures are foundation in computer science and are often used in real-world systems like browsers, job scheduling systems, and algorithm solutions. By implementing the QI manually, students not only understand its international mechanism but also improve their algorithm thinking and Java programming skills. This hands-on approach provides clarity and confidence when dealing with more complex data structure in future projects.